Now we're going to learn something similar to Rolle's theorem, but it's actually a little more powerful, and it's called the mean value theorem. So the mean value theorem says that suppose that y equals f of x, so your function is continuous at every point on an interval from a to b, and is differentiable on every point of that interval. So that's the exact same thing as Rolle's theorem. Then there is at least one point c at which f prime of c equals f of b minus f of a over b minus a. So notice, unlike Rolle's theorem, this doesn't require that f of b equals f of a. They can be anything. Okay, and then this tells us something about there's some point where this derivative is equal to this special value. Well, let's see what's actually happening here. So if we have our coordinate axes, and let's just say this is a and this is b, okay, and maybe we have something like this. Okay, so the graph could be doing all sorts of things, but so this is our point at A, and this is B, and you know the graph could be going on, but we're just really worried about this, or interested in the part between A and B. So this would be the point A, f of A, and this would be the point B, f of B. And if we took the secant line between those two, so this right here, then the slope of that line would be f of B minus f of a over b minus a. So what we're saying is there's some point where the derivative of the curve is equal to the slope of the secant line between those 2 points. So again, unfortunately this doesn't tell us how to find it, but we would want something where the tangent line was parallel. So maybe right here, this derivative, the slope of that secant line, would be parallel to the slope of the tangent line would be parallel to the slope of the secant. So that would be our C. Okay, now another way of thinking about this, if we have these two values A and B, the slope of the secant line, this red thing, is the average rate of change. And the slope of the tangent line at C, that's the instantaneous change. At C. So what the mean value theorem is kind of saying here is there is some point C, or some x value C, where the instantaneous rate of change at C is equal to the average change from A to B. Okay, so think about even just driving in your car. If you drove for 3 hours and you had gone 180 miles, you would know you were going on average 60 miles per hour. And this is telling you that at some point you would have had to have been going exactly 60 miles per hour. Now, this theorem just tells you that that has to be true, not where to find the C. But so we have a couple of corollaries, and corollaries are just things that you would use this theorem to prove. So we're not actually going to prove them or anything. And there are things that you might have already kind of figured out. But it says if the derivative is 0 at some point in the interval, then this should say not at each. Oh, at each. So if your derivative is 0 at every point on an interval, then your function has to be constant on that interval. Okay, and our next one just says if two derivatives are equal, then the functions have to be equal, except you could add a constant to the end of them. Okay, and we'll actually come back to that later in the course and talk really about what it means. Okay, so here's a problem we're going to work out. It says find the value C that satisfies the conclusion of the mean value theorem for f of x equals x cubed minus x squared on the interval from -1 to 2. So let's write out kind of what that conclusion is. So for the mean value theorem, it says there's some point where f prime of c is equal to f of b minus f of a over b minus a. So this is our a and this is our b. So f of b would be f of 2, which means we'd plug 2 into our function, so we'd have 8 minus 4, we have 4. And f of -1, or f of a, would be -1 minus 1, so it would be -2. So we're saying there's some point c where f prime of c is equal to 4 minus -2 over 2 minus -1. So we get 6 over 3, which is equal to 2. So there's some point where the derivative is equal to 2. Now let's actually take the derivative. It'd be, so f prime of x here would be 3x squared minus 2x. So f prime of c just means plug in c. So we'd have 3c squared minus 2c equals 2. And we want to solve that. So we could do this. And we can try to factor it. So we'd have 3c and c. Now we need two numbers that multiply to get 2. So let's try minus 2 plus 2 minus 1. So that would give us 3c squared minus 3c. Wait a second, what is it? Okay, so I don't think this is going to factor, but we could use the quadratic formula. So x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. So we'd have 2 plus or minus the square root of 28 all over 6, and you could put this in your calculator and get a number. So, square root of 28 over 6. So this is going to give you approximately 1.22 or -0.55, and either of those values would work here, so that's what we're looking for.